Good morning, geometry. So today we're going to be working on the week 4 notes, which can be found in the Thursday 924 folder in week 4 in Schoology. And if you open them, you'll notice that this is only 2 pages long. So it's going to be an easy week with any luck. And what we're learning today is the segment addition postulate. So the segment addition postulate has these, well, first we need to work with these vocab words here they give us. So measuring segments, typically, I mean, if you're literally shown a segment, you might want to use a ruler, but that would be in like inches or centimeters or whatever it is, but it doesn't tell you what the units are ever. Well, maybe it will, but it's most likely not going to tell you what the units are. It's just going to say, oh, this segment is 5. And then you would have to accept that that is 5 and then use that to determine the lengths of other segments. So the distance between 2 points, A and B, so the 2 endpoints of the segment, or the length / measurement of a segment AB can be written as, well, that's just going to be, I'll use a different color. I'll go with this one. It can be written as AB with the line over it, just like we've done the segments before. So like that was the symbol we used for segments. So congruent segments, we have if AB equals CD, then the segments are congruent. So this would be written as, so AB, and it's a segment, and then we're going to say equals, but to denote that the segments are congruent, we're going to put a little, I don't know what I would call that, a little wavy thing over top of the equal sign. And that would be congruent to CD. So that just means they're the same length. These 2 segments would be the same length. And we've seen that symbol before on one worksheet we did, but not a lot of people knew what it meant. So now we know it means congruent. It means they're the same length. And then midpoint of a segment. So we've talked about midpoints before. But the midpoint is a point that divides a segment into 2 equal segments. So the midpoint is exactly between the 2 endpoints. So the distance between one endpoint and the midpoint is going to be the exact same as the distance between the other endpoint and the midpoint. So a line, array, or a segment that intersects a segment at its midpoint is said to divide the segment and is called the segment bisector. And I believe we've seen that before. We've seen this vocab term before. And actually, I'm not sure if this is still Unit 1, because I know Unit 1 was transformations and vocab, and this isn't really transformation. So this might actually be Unit 2. I don't know. I've just looked at the curriculum map, so I haven't figured out if this is into the next unit yet. All right, so maybe it is. Maybe we're on Unit 2, I don't know. I'll check, I'll let you know tomorrow. All right, so then we have this diagram here with this line going through the segment, and we can tell that it's going through the midpoint of the segment. Well, it's a little bit off there, but it's going through the midpoint of the segment because of these symbols right here. remember, when we have those symbols on segments, it means the two segments are congruent. They're equal to each other. So that means the segment AB is congruent to the segment BC. So in the diagram, the point B is the midpoint of segment AC. And line M, remember when we talked about naming lines and naming segments and all that stuff, we said that lines, you could either pick 2 points on that line to name it, or you could just use one lowercase letter. And M here is the lowercase letter. We haven't seen any examples of just one lowercase letter yet in this class, but here it is. And line M is a segment bisector. Of, well, it bisects AC. So in the diagram, B is the midpoint of AC, and M is a segment bisector of AC. So now we're going to apply some mathematics to it. So this example here, if H is the midpoint of GI, so they tell us that H is exactly between G and I, it wants us to find GH. So this means that segment GH must be congruent to segment HI. Therefore, this 5x plus 2 has to equal this 9x minus 10. So I'm going to work with that. I have 5x plus 2 equals 9x minus 10. And I just want to solve for x here. Because even though the question is find GH, I can't find GH unless I know what x is. So I will add 10 to both sides. And once I do, I got 5x plus 12 equals 9x. And then I'll subtract 5x from both sides. So that gives me 12 equals, and 9x minus 5x is 4x. And my final step is divide by 4. So I got 3 equals x. So x equals 3 here. But that's not the question. The question was find GH. And I don't know why they only put the line over GI. Like every single other segment that they name on this worksheet, they don't put a line over it except for GI. So clearly they have the capability to put the line over GI, but they just didn't. Or every other segment, but they just didn't. So I don't know why. But anyways, we want to find the length of GH. So GH is 5x plus 2. So GH equals 5. And then we know what x is. We know that x is 3. So 5 times 3 plus 2. So 5 times 3 is 15 plus 2. So 17. The length of GH is 17. And it doesn't give us units. It doesn't tell us what the units are, so it's just 17. And since GH and HI are equal, if I had plugged 3 in for 9x minus 10, I would have gotten 17 as well. Which means the entire length of GI is going to be 17 plus 17, which is 34. But it didn't ask me to find any of that. It just asked me to find GH. The worksheet you guys are doing later, I believe there is a question or two where it does ask you to find the length of all four. It asks you to find like GH, HI, and then GI, and X. Okay. Continuing on, we have the segment addition postulate. And this is our first postulate, really, that we're learning in this class. I mean, we learned the linear pair postulate and the, what was the other one? Oh, the vertical angle theorem. So this one is the first one that has to do with segments instead of angles. So if A, B, and C are collinear points, hopefully we remember collinear means on the same line, and B is between A and C, so just imagine a line with A and C on the ends and B somewhere in the middle. Then that means that the length between A and B, so the length of segment AB plus the length of segment BC equals the length of segment AC. So the distance between A and C can be determined by finding the distance between A and B and then adding the distance between B and C, because B is between A and C, and they're all on the same line. So we are going to use this now. We're going to use this line PQR to answer the following. So if PQ equals 9 and QR equals 28, find PR. So they're telling me that this distance here is 9, and then this distance here is 28, and it wants us to find the distance of the whole thing. So we can see this is an application of that segment addition postulate. So all I really need to do is add the 9 plus 28 now to find the distance between P and R. So 9 plus 28 is 37. And that's my answer. And then we have a similar question, but not quite the same. So for question B, if QR equals 17, so I'll go ahead and label that, and I'll do this one above. So QR is 17, and PR is 21. So PR, that's the entire thing. So this one is a bit different because they give us the entire thing and they give us a smaller part. So that's 21. All right, so according to my segment addition postulate, or using the segment addition postulate, I want to find PQ. So according to the segment addition postulate, I know that PQ plus QR, which is 17, equals 21, which is PR. So all I need to do to find the length of PQ is subtract that 17 from both sides. So that means PQ equals 4. The distance between P and Q is 4. Sorry if I'm going a little bit fast, but you know, it's a YouTube video. You guys can pause it whenever you need to. Okay. So that was an application of the segment addition postulate. And this next example, we are going to be getting into the segment addition postulate with variables in it. So on this one, they say EG is 71. So I'll go ahead and label that. So this entire distance is 71. Then they say EF is 8x minus 17. Okay, I can do that. So 8x minus 17. And FG is 5x minus 3. So this distance here is 5x minus 3. All right. It wants us to find the value of x. So what I'm going to do is I'm going to use my segment addition postulate. So I know that EF plus FG should equal EG, which means if I do 8x minus 17 plus, well, 8x minus 17 is EF plus FG, so plus 5x minus 3. That should equal EG, which is 71. And this looks like an equation that we know how to solve. So I'm just going to solve it. First step is to combine like terms. So I have 8x plus 5x gives me 13x. Negative 17 minus 3 is negative 20. And that equals 71. All right, this looks pretty simple to solve now. Gonna add 20 to both sides. So that gives me 13x equals 91. And divide both sides by 13. And if you know your times tables, you'll know that 91 divided by 13 is 7. And it just asks us to find the value of x, so that's our answer. X is 7. Hopefully that made sense. And we are almost done with our notes for today because, again, this is a short week for notes. And there is an assignment in Schoology after this. And I believe it should all be solvable using what we learned today on these notes. But let me know if it's not, like come to my office hours or something. And I'm actually looking at it now. I have it printed off in front of me. It looks like there's a few problems where they throw a little extra information at you. So they're like telling you the length of segments that you really don't need to be able to solve the problem. So be careful with that. But yeah. Okay. And this next question is our final question for today's notes. So it says TV is 14x minus 8. Okay, so TV is 14x minus 8. This whole distance here is 14x minus 8. TU is 9x plus 2. Okay. So TU is 9x plus 2. And UV is 5. Okay. So that is 5. And I know that I went a little bit too far with my TU, but that's fine. Okay, now we will use this and the segment addition postulate to find the measure of TU. But first we have to find the measure of x. And then we can use that to find the measure of TU, just like we did in the first example we did before we even got into the segment addition postulate. So the segment addition postulate tells me that 9x plus 2, which is TU, plus 5, which is UV, should equal 14x minus 8, which is TV. So let me write that out. 9x plus 2 plus 5 equals 14x minus 8. My first step that I'm going to do is combine like terms on the left side. So 2 plus 5 is 7. So 9x plus 7 equals 14x minus 8. And then my next step, I guess I'll add 8 to both sides. So those cancel out. 7 plus 8 is 15. So I got 9x plus 15 equals 14x. And then my next step, subtract 9x from both sides. So then on the left side, I'm left with just 15, and 14x minus 9x is 5x, and divide both sides by 5 to get my answer. Those cancel out, and 15 divided by 5 is 3. So x equals 3. 3 equals x. And I've said this before, but I'll say it again. This is geometry. We are dealing with the lengths of segments and the measures of angles. We will almost never see negative numbers in this class. So if you solve something and you get a negative number, chances are you're wrong on something. But especially if it's a distance. If it's saying like, calculate the distance of 9x plus 2 of TU, and you get a negative number, you're wrong about something. But if you're calculating x, that might be a negative number. I guess it's possible for it to be a negative number and still get a positive distance when you plug it in. But yeah, x will, or almost all the answers in this class will be positive numbers. All right, so x equals 3, but that wasn't the question. The question was find the measure of TU. So I'll actually go back and uncircle that. So find the measure of TU, and TU is 9x plus 2. All right, so TU equals 9, and instead of x, well, x is 3, so I'm going to do 9 times 3 plus 2. 9 times 3 is 27. So I got 27 plus 2, and 27 plus 2 is 29. So the answer is 29. The distance of segment TU is 29. And if it had asked me to find the distance of TV, I could just plug it into 14x minus 8, or I could just use this 29 and add the 5 to it, and it would be 34. So that is all of today's notes. We will get into the angle bisector stuff, which you can see here, tomorrow in class. So please take these notes. I mean, if you've gotten this far, you've probably taken the notes. But yeah, and then work on the segment addition postulate practice worksheet, which I have left in Schoology. Yeah, keep up the good work, guys. Thanks.